For almost 2 decades, John Pasternak has traveled and worked the deserts, jungles and cities of the world as an actor, director, stuntman and special effects coordinator. His series of videos will show you all the professional techniques and what can be achieved in the making of your own home movies, with materials and equipment available to everyone. The series will cover all aspects of filmmaking, enabling you to take your audience from outer space to 20,000 leagues beneath the sea. Adventure, true life, and horror. With John Pasternak's Movie Maker series, the sky is no limit. If you can press record, you can make a movie. Should you decide to attempt to make any or all of the special effects you've just seen, remember, use the utmost caution in all respects and at all times. Movie Maker accepts no responsibility should anyone viewing this video sustain any injury whatsoever while attempting to make or film any of the effects shown herein.
Welcome to John Pasternak's Movie Maker series, Special Effects Volume 1. Working on a storyboard.
Before any filming can begin, a script needs to be written. This will give a description of the scene and the action of the actors and the camera. It's also necessary to provide dialogue, the words or lines each of the characters are required to speak. As there was no dialogue in the clip you've just watched, a script was not used, but all the action was set out in the form of a storyboard, a kind of comic strip. The whole film is laid out in this way, one picture for each camera shot. It's not necessary to be a great artist, as even a very simple drawing will show your cast and crew what you require of them. Using sketches helps you, the director, visualize the finished product. It's better to make decisions and mistakes on a piece of paper than on the set of the film. When your storyboard is finished, a shot list is made. Each shot is then crossed off as it is completed.
Producing fog.
Video tends to give a very clear, clinical look, which flattens the scene out. Shooting on film gives more depth because of its grainy, slightly diffused picture. Another way to achieve the same effect on video is to fill the air with smoke. Now, the only way to do this safely is by spraying a water-based fluid called fog juice onto a hot surface. Fog juice is made for smoke machines, the type used in nightclubs or stage shows. The smoke for this clip was made by spraying the fog juice from an atomizer or plant spray onto an old iron at a high temperature setting. Fog juice liquid is available in 1 litre or 5 litre containers from stage or theatrical supply houses.
The retractable knife.
The knife that made the first incision in the arm was a specially built prop called a retractable. When the knife was pushed against the skin, the blade actually slid up into the handle, and a syringe pumped artificial blood to the skin as the blade was seemingly drawn through the flesh. The knives are the type that have an extendable blade with sections which can be broken off as they become blunt. One of the knives was stripped. The blades were, of course, razor sharp, so the first thing was to blunt one of the blades. This was achieved by hand on a stationary grindstone, as it would have been difficult to hold the blade on a moving wheel, and it could have shattered, so it was rubbed down, making sure to round off the point. Next, a needle file was used to make a groove in the handle to hide the thin plastic tube which would carry the artificial blood. The groove was difficult to start, as the plastic was quite hard and the file slipped off the edge. Now, if a needle file was not available, a strip of emery cloth folded in the middle would have done just as well. When the groove had been cut as deeply as possible without cutting right through the plastic, the blood tube was glued into place. Later on, the tube was hidden, taped to the actress's arm. The end of the tube was then trimmed off. The next piece required for making this prop was a spring. Model stores sell packs of assorted springs, and a compression spring that was just strong enough to push the blade out was selected. The knife was then reassembled, allowing the blade to slide in and out of the handle against the spring. A piece of old packaging from a set of fire alarms provided the ideal solution to the problem of the spring curling up under compression and fouling against the actress's hand. The packing was clear, therefore, if there was a difficulty, the ability to see the spring and blade operating was very helpful. using just enough glue to hold the piece in place meant that should the knife need to be dismantled at any time, it could be done without too much damage to the rest of the prop. The syringe used was a large one, as a lot of artificial blood can be expended on each take. Stage blood can be purchased, although it is quite expensive if bought in small phials like this one. Artificial blood can be made fairly simply with red food coloring to start with. Add some glycerine to stop it drying out, and then some corn syrup, honey, maple syrup, or anything to give it body, even tomato ketchup.
Applying latex.
Latex is the sap of the rubber tree. It's available from theatrical makeup stores and used for making all kinds of appliances, such as rubber noses and chins. It can be used to wrinkle skin and to make skin look old, which is why it is often sold as old age stipple. The latex was stippled on to clean dry skin with a piece of stiff sponge. It does not stick to damp or greasy skin, and sometimes it's necessary to clean the area with a cleanser or surgical spirits. The latex pulls off the skin after use, but likes to grab the arm hairs, and if it gets into cloth, it's there permanently. However, soap and water will remove it from the skin and the hair. Once latex has been applied, it will air dry, or it can be dried with a hairdryer to speed up the process, though it's necessary to exercise caution, as some dryers generate a lot of heat and the skin could blister quite easily. Ordinary talcum powder stops the latex sticking to itself and also helps to thicken the rubber skin. There are different grades of latex. The one used here was a facial grade, so it was safe to put directly onto the skin. However, some people react badly to latex application, so it's advisable to test the latex on a sensitive area of the skin first. The actress wore a small patch of latex on the inside of her forearm for several hours to check for any allergic reaction. In this case, there was none, so it was safe to proceed. A second layer was applied after the first had set and was dried in the same manner. This time, however, a dark face powder was used, which gave more of a flesh tone, and the rest of the arm was made up to match.
The Mechanical Arm, Part 1.
In the film clip, the first cut was made with a knife. Then, the skin was pulled back to reveal the metallic body effect underneath. For this, the latex skin was first blistered by pinching it a little and pulling it away from the arm, then carefully slit open with a small pair of scissors. The aluminium mesh used for bridging rust holes in cars is sold in small sheets and gives the repair material on the android's arm something to cling to. It can be purchased in auto care shops. It's cheap and easy to work with. A small section was cut carefully with scissors before it was slipped under the latex skin. It was necessary to put powder on the inside of the latex next to the real skin. Otherwise, it would have been difficult to get the piece of mesh underneath without everything sticking together. Next, plenty of artificial blood was poured on. The shot of the opening up of the arm was very short, just enough to give the audience the idea of what was taking place. The piece of mesh was removed after the shot and pre-cut. Then, with the camera low and to the side, the mesh was replaced.
mechanical arm, part 2.
The next appliance was the internal workings of the arm, which started life as an empty beer can. The can was cut open and a section snipped out, as shown. Paint was rubbed off with a piece of emery cloth or sandpaper, with the metal left curved, as this helped in better fitting the shape of the arm. A channel was made by scribing a line with the edge of a screwdriver on one surface to create a U-section. Then the metal was turned over, and the same thing done in parallel on the other side. The metal could then be folded to shape without it creasing or deforming. The mechanical movement was produced by pulling a piece of fishing line back and forth through a piece of thin gauge copper pipe, which was found lying around the workshop and probably came from a car brake system. Plastic tube could have been used instead. The tubing was carefully bent into a U shape so as not to flatten it, and moulded into a radius that fitted comfortably into the channel. A piece of fishing line, long enough to be doubled through the pipe and operated from off-screen, was cut and threaded through. The pipe was then stuck down with a two-part strong bonding epoxy resin. The two tubes of resin were mixed on an odd piece of card and spread onto the metal. Epoxy usually hardens in about 5 minutes, but goes on strengthening for another 24 hours. Although the bond was very strong, it would not have stuck at all if there had been even the slightest trace of grease or oil on either surface. Next, an interesting piece of plastic from the scrap bin was selected and stuck onto the fishing line. Its complicated shape attracts the viewer's eye, and while they're trying to recognize it and listen to the mechanical sound effect, they are not concentrating on what is making it move. Another piece of aluminium mesh was then cut to fit over the channel in the appliance, and this was also stuck down with the epoxy mixture and left to dry. Because the appliance was seen later in the clip, the mesh was cut open and bent out to resemble the shots already seen. The camera angle is very important with this and any other effect. This particular shot will only work if the camera is at exactly 90 degrees to the appliance while it is on the arm. The appliance was slipped under the latex skin as before and disguised with plenty of artificial blood. Moving the finger and the fishing line at the same time gave the impression that the arm really was mechanical. The finishing touch? An empty staple gun and pieces of flattened wire already stuck to the skin.
The mechanical eye.
The first item required was a table tennis ball. This was stood in a ring of plasticine to stop it rolling around. Next, a ballpoint pen was stripped and the end glued to the ball. A pencil was the only writing instrument that would make a mark on the surface of the table tennis ball, so a line was drawn about a quarter of the way up. Then, a small hacksaw with a fine-toothed blade was used to carefully cut the ball to form a shallow cup. Next, a needle threaded with fishing line was passed twice through another table tennis ball, so that it was held by 4 pieces of line at 90 degrees to each other. The lines were glued where they entered the ball. The pen was then sawn about 2 inches from the cup. 2 pieces of twin-core electrical cable were cut off, and the ends split and stripped back to the copper core, just enough for a pair of pliers to grip the bare copper wires and pull them out. The cup was then marked off in quadrants, 90 degrees apart. One end of each of the plastic sheaths was glued to the marks on the cup, so that the wires from each pair were set out opposite each other. Then the second pair were glued on. These sheaths held the control wires for the eye. Each of the 4 fishing lines were then threaded through their appropriate sheath. With all the control cables in position, the eye could be controlled by pulling the fishing line and holding the sheaths still. A stiff artist's brush was required for the next stage, and to protect it, washing up liquid was rubbed well into the bristles and handle and then squeezed out. An old plastic container with flat sides was also needed, along with another saucer of latex. Using the brush, 4 strips of latex were painted onto the container and set aside to dry. They could have been dried with a hairdryer to speed the process up if necessary. Blue and red streaks were then painted onto the clear dry latex. The latex was then peeled off. As it stuck to itself easily, the strip was able to be rolled with the end of the finger into a rough V shape. These strips were to become the muscles of the eye, so they had to be fairly irregular, but about the shape the audience would expect eye muscles to be. The red and blue streaks represent the blood vessels. When the shape was right, a sprinkling of talcum powder enabled the rubber latex to be taken from the plastic container while it retained its shape. The muscles were then glued over the points where the control wires emerged from the surface of the ball, so as to hide them. Then, the ends of the rubber muscles were glued along with the sheaths to the end of the pen barrel. The rubber acted as a spring and helped to return the eye smoothly to a central position. More plasticine was required, this time a large piece to enable the eye to be held steady for painting. Artists' acrylics work well to colour the eyeball, which was painted to match the actress's. First, the pupil. Then the basic iris colour, which was green. This took a little care and time, so as to get the shape right. Next, the thin black line around the iris. The veins were painted in with a very fine brush. Thin streaks crisscrossed from the muscles towards the iris. Ordinary nail varnish painted over the whole of the surface of the eyeball gave a permanent, shiny, wet finish. To add a mechanical, electronic look, pieces of old broken radio and bits of wire were stuck all over the surface, being careful not to impede the movement of the eyeball itself.
The Firearm Shot.
The laser beam that was projected from the sight on the gun was actually the edge of a piece of light-gathering plastic bought from a craft shop and is normally used for making signs. The sheet was cut diagonally and the pieces stuck together, giving greater thickness to the beam. A length of square section plastic gave it a means of attachment to the gun, which was actually a plastic toy. The sight was an old torch. The torch needed some kind of holder, so plastic electrical trunking cut into 2 short lengths with a hacksaw, tried for size and glued together, proved to be the ideal answer. A clamp, which would hold the laser attachment tightly while it was being filmed, but could be easily detached, was made by holding 2 safety covers from disposable razors firmly against the plastic rod and in position on the torch holder, then gluing the safety covers only to the plastic trunking so that when dry, the laser could be removed. 2 more safety covers, glued to the top of the gun, provided the clearance needed for the torch to fit properly when the sight was put into place. Matte black paint gave the sight the proper look. Also, being a matte finish, it did not glare and reflect the lights. To establish the effect of the laser being switched on, the gun was first clamped so that it would not move, as shown here with a G-clamp. The camera was also locked down and a few seconds of film shot. Then, the pause button on the camera was pushed. Carefully, the laser was attached so as not to move the gun. When the pause was pushed again, the effect on film was such that the laser suddenly appeared to switch on. The shot of the android's POV, or point of view, was achieved by taping the laser attachment under the lens of the camera and looking along the edge of it. A thin piece of fishing line was tied to a beer can. The can was then dropped from out of frame, giving the appearance of falling into the line of sight, and then the can was jerked away. As the effect on film was such that the beer can was supposed to have been hit by a bullet, it was flattened before a bullet hole was made with a pair of scissors. Finally, the can was literally thrown into the shot.
Facial preparation.
The sequence of the eye being pulled from its socket was one of the more involved effects in the making of the video. The process of making the rubber face begins with soft soldering wire being used to take the shape of the model's own face and then transferred to cardboard. The cardboard was then cut out. Old clothes and protection for the hair was a must, as the procedure is quite messy. The technique demonstrated here was carried out with a male model, but male or female, the process is the same. Vaseline was applied to all facial hair, as otherwise the alginate used for this effect would stick. The model was made comfortable, and the cardboard put in place with a tube supplied for breathing through. Alginate was used to take the actual cast of the face. Alginate is a dental impression material and can be purchased from dental suppliers. Before being applied, it was shaken to fluff up the powder. About 3/4 of a cup was tipped into a plastic container and 1 cup of water with the powder. The mixture was stirred to a thick cream, working quickly as alginate sets rapidly. It was then spread over the face carefully so as not to trap any air bubbles, working from the forehead down. Within a few seconds, the alginate sets due to the heat of the skin. Before it sets, stiff pieces of cloth were let into the surface.
Plaster casting.
Plaster of Paris was mixed into water. This was then laid on the outside of the alginate cast to give it strength. The plaster adhered to the pieces of cloth in the alginate, assisting in holding the entire facial mold together. A piece of cloth was then laid over the wet plaster and another layer of plaster added. The cloth helped stop the plaster cast from cracking. When the plaster was dry, the whole cast could be pulled smoothly away from the face. More plaster of Paris was then mixed. This time the container was bumped several times on the bench to bring any air bubbles to the surface, which were then scraped off. A horseshoe of plasticine held the cast steady, while the first layer of plaster was flicked into the cast. This forced any air away from the surface. The rest of the plaster was tipped in and smoothed over. Next, a piece of wire bent in a loop was let into the wet plaster. This made the cast easier to grip and subsequently handle. When the plaster had set, it lifted easily out of the mold. The best time to make any repairs to the surface was while the plaster was still damp and a little soft.
Making the rubber face.
After leaving the face to dry for several days in an airing cupboard, it was fixed onto a board with plasticine all the way around the base. Beeswax polish was applied with a soft cloth and allowed to dry. Then polished. A PVA release agent was painted evenly over the whole surface of the face, extending down to the base. As the next step involved using fiberglass and chemicals, plastic gloves were necessary to protect the skin. These gloves were supplied with the fiberglass repair kit used for the mold. When mixed with its hardener, the gel coat formed the first layer of the mold against the face and picked up all of the surface detail. It was worked carefully into all of the crevices and dips, and then extended over the plasticine and onto the baseboard. The gel coat was left until tacky and tested by touching the baseboard, not the surface of the cast, which would have been spoiled. Glass fiber tissue is a very fine fiberglass mat. It was cut to the rough shape of the face with a couple of inches to spare all the way around. The fiberglass kit contained the resin and a graduated mixing cup. It also contained the hardener, which activated the resin. The tissue was then wetted out thoroughly with the activated resin until the fibers began to fall apart. The tissue was then laid over the face before the brush was used to flatten it against the surface, getting into every crease and crevice and pushing out all of the air bubbles. Before the first layer was completely dry, a piece of the heavier chopped strand mat supplied with the kit was laid over the top and again worked into the face as before. More resin was added because of the heavier fibers in the mat. When dry, the mold was pulled away from the plaster, washed and dried off. Next, reusable vinyl rubber casting material was melted in a pan carefully so as not to allow it to get too hot and burn. When liquid, it was poured into the glass fiber mold, which was supported by dry cloths. The rubber was very hot at this stage and would have boiled any water it came into contact with. For this reason, thick gloves were worn when working with it. When cool, the face was taken from the mold.
Finishing the face.
Using acrylic artist's paints again, the whole face was given a white base coat. This was much easier to work from than the dark colour of the rubber. Next, a flesh tone of white, yellow ochre and just a hint of red was painted all over the face. Using the paints, the actress's makeup was mimicked. Blusher, lipstick, and so on. Because the shot was so quick, a cheap acrylic wig was used and a piece of this was taken to make the eyebrows. These were applied in thin layers so that the hairs fell in the right direction. Starting at the end closest to the ear, a small bunch of hair was glued on, then another, and so on until the whole eyebrow line was covered. The hair was then cropped to shape. A sharp craft knife was used to cut right through the rubber along the line of the eyelid. To film the effect, the mechanical eye was threaded into the face, and on action, the actress used her own hand to draw the eye out.